Hello everyone, welcome to this video where we are going to solve some trigonometric equations, which are equations that involve trigonometric functions. So one thing about trigonometric equations is that they generally have infinitely many solutions, if they have any solutions at all. And at least for this video, we're going to consider some restrictions to this so that we only have finitely many solutions. Okay, so there are a few different questions that we're going to look at. I'm just selecting them from the textbook. In fact, I haven't solved them myself yet, so we're going to solve this together. It'll be a more disorganized video than the previous ones. And so anyway, let's get started. We've got, for this first equation, 2 times sine of theta plus 3 equals 2. One of the first things you generally want to do with a trigonometric equation is solve for the trigonometric function itself. So let's subtract 3 from both sides. We get 2 sine theta is equal to minus 1. Let's divide both sides by 2. When we get sine of theta is minus 1/2. So at this point, it's generally a good idea to graph the functions involved to get an idea of how many solutions we're looking for and how we're going to apply inverse trigonometric functions. So we've got sine of theta. Sine of theta looks like that. Goes up to 1, goes down to minus 1. I'm also going to continue this one more period, or half period on the minus side. So it goes up to 2 pi. That's pi. And then we want to know when is sine equal to minus 1/2. So I'm going to draw the line y equals minus 1/2 right here. So we'll call this minus 1/2. And in our particular interval that we care about, so theta greater than or equal to 0 but less than 2 pi, we can see that there are 2 solutions that we're going to get, and we need to figure out what those are. So what we're going to do is we're going to calculate using the inverse trigonometric function some solution, even though it's not in this interval, and then we'll use that to figure out the other 2. So what does inverse sine give us? So in the previous video, it was arc sine, but the notation we're using in this class is sine inverse. Sine inverse of minus 1/2. And the thing about it is, remember that the way that we get an inverse sine function is that we restrict our function to pi over 2 on the positive side and minus pi over 2 on the negative side. So we restrict to here. And then that means that if we want to see what the inverse function is, we just see for a given y value, what is the input that would give us that. So this particular intersection point is sine inverse of minus 1/2, because it's in the correct interval for this for the definition of the inverse function. Okay, so if we remember our tables of sine functions and all that, we might remember that this is minus pi over 6. Another way to see this is that, let's see, sine theta is minus 1/2. If I do the negative of both sides, I have this. Sine is odd. And when is sine of something or what's the something so that sine of it is 1/2? That would be pi over 6, and that's why it's negative pi over 6 over here. Anyway, could also use some calculator or something to find that value. So we've got that, but that is not in the correct interval. One way that, so we want to get it into the correct interval, And so if we add 2 pi, we get that point. And then what else can we do? Well, we want to like flip it over. So like, what am I saying? So first of all, this point is going to be minus pi over 6 So this is minus pi over 6 plus 2 pi. And then we also can use some sort of symmetry here. So if this what am I trying to say? So we're going down by pi over 6, but we can then from pi go up by pi over 6. So this one would be pi minus negative pi over 6. That's how we get the other one, which is pi plus pi over 6. There's probably a better way to explain this one. I'll try again later with some of the future problems. So solutions in this interval are, in set notation, we've got pi plus pi over 6 for the lower one, and also 2 pi minus pi over 6 for the other one. Yeah, so in general, I think it's good to graph the sine function or cosine function under consideration. Try to see where it's having that particular value, in this case, minus 1/2. And then you can use your inverse trigonometric function to then find a point and use that to get the rest of them. Okay, so that was solving the first one. In our next problem, we're trying to find the solutions of 4 times cosine squared of theta equals 1. So let's divide both sides by 4. We want to isolate the cosine function. 1/4. And then this is cosine squared, so let's take the square root of both sides. So 1/4 is positive, so we can just take the square root, cosine theta, and then don't forget the plus or minus. And so that's taking the square root. And that gives us that cosine theta is plus or minus 1/2. So the situation is very similar. We've isolated the trigonometric function, and now we want to plot that function to try to figure out how many solutions there are and try to figure out where they are. So here is cosine, goes up to 2 pi. 1 minus 1. And then we want to know when it's either positive 1/2 or negative 1/2. So 1/2 minus 1/2, and that gives us 1, 2, 3, 4 different solutions. Now it's just a matter of figuring out what those are. So the first 2 solutions are in the correct interval for the inverse cosine. So this goes up to pi from 0. So these are in the domain of for using cosine inverse. For these other 2, we're going to have to use some tricks to then figure out what those would be. But we can use the symmetry here, which is that if we do 2 pi minus each of these solutions, we get the other of them. So let's see. cosine inverse of 1/2. Let's see. How do we find that? Well, we can look at a table. For me, you know, I'm having to talk and explain what I'm doing all at the same time. But okay, so this should be pi over 3. And then for the next one, cosine inverse of minus 1/2. This is 2 pi over 3. Okay, so that's the first point and the second point. Now we need to get the other two. And so, well, I guess we can use the symmetry idea. If we're reflecting it over pi here, so flipping it like this, then the way that works, 0 becomes 2 pi, 2 pi becomes 0. We just do 2 pi minus each of those to get the other one. So if we take this distance here, then 2 pi minus that distance gives us this point. So the solutions are, and that should be a better curly brace. Okay, pi over 3, 2 pi over 3, then 2 pi minus that one. I'm doing these in order. And 2 pi minus the first one. So we get 4 solutions here. Okay. Yeah, so just to summarize the idea again, we isolate the trigonometric function, and then we figure out how many solutions there are, and then we try to use some method to figure out what the solution, or where those points are. And I'm making use of the inverse trigonometric function to help me out there. Let's look at our third of four problems. So in this case, sine of 3 theta is minus 1. So for this problem, the trigonometric function is already isolated. And what we need is to simply plot sine of 3 theta and then try to use that knowledge to then find all the solutions. So remember, so as we saw before, we need to plot something like this. So in this case, the amplitude is 1, and then the angular frequency is 3, and the phase is 0. So the period is 2 pi over 3 from doing 2 pi divided by the angular frequency. But the important thing is that from 0 to 2 pi, so let's see, I'll break this into 3 parts. So this is 2 pi over 3, 4 pi over 3, and then that's 6 pi over 3, also known as 2 pi. It goes through 3 cycles, which I'm going to retry that. That was bad. Okay, so it goes through 3 full cycles in the period of 0 to 2 pi. And we want to know when is it minus 1. And minus 1 is right down here. And we see there are going to be 3 solutions. We can figure out where this one is easy enough. So I guess the fact is that, so this is 2 pi over 3 to go through this full cycle. And then if you break that into 4 parts, that goes up to the top, back to 0, down to the bottom, back up. So if we take 3/4 and multiply it by 2 pi over 3, we get where it occurs. So I guess this is at pi over 2. Yeah, pi over 2. And we know the period, so if we add the period to it, we get the next one, and then add the period to that, we get the next one still. So we've solved it. Now let's just write out what the solutions are. The solutions are pi over 2, pi over 2 plus 2 pi over 3, and then pi over 2 plus 4 pi over 3. So those are the three solutions from adding in one additional period and 2 periods to get the other 2 points. Okay, let's finish off with a trickier problem. This one is 2 cosine squared plus cosine minus 1 is 0. So we want to isolate the cosine, and the way that we can do that is pretend that cosine is a variable. So we could do that with let's say x equals cosine theta. This is 2x squared plus x minus 1 equals 0. So we want to solve for the trigonometric function. So we want to solve for x. And let's just use the quadratic formula. X is negative b minus 1 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is minus 1 plus or minus the square root, let's see, 8. It's negative 8, and it's 1 minus negative 8, so we have this. And this is minus 1 plus or minus 3 over 4. So minus 1 minus 3 over 4 gives us minus 1. And if we do minus 1 plus 3, we get 2 over 4, which is 1/2. Okay, so we have two cases. Either cosine is minus 1 or cosine is 1/2. So let's plot our cosine. We want to know when is it minus 1 or when is it 1/2. So there are 1, 2, 3 solutions. When it reaches the bottom, that's at pi. So that one is straightforward. But now we want to know when is it 1/2. So let's see. So the cosine inverse so the first one here is cosine inverse of 1/2. So when is the x coordinate equal to 1/2 for a particular angle? Pi over 3 works for that. That's pi over 3. And then the next time it happens, it turns out to be 4 pi over 3. So the other, we can also do this flipping over sort of argument. So we do 2 pi minus pi over 3, which is 6 pi over 3 minus pi over 3, which is is it really 5 pi over 3? I am going to check on a calculator just to be sure. The cosine of 5 times pi over 3 is indeed 1/2. Okay, so I misspoke with 4 pi over 3. Right, so let's just accumulate this all as a solution. So the solution is we've got pi over 3. That's the first one. Our next one is at pi. And our last one is at 5 pi over 3. So we've solved 4 different trigonometric equations. And just to say the main idea again, it's you solve for the trigonometric function. And then my method is that you plot that trigonometric function and then analyze where the intersection points are with horizontal lines for the particular values it's supposed to equal. Okay, so we're going to see more of this in future videos or future live lectures, and I'll see you next time. Bye.